So today now we will talk about first the very basics of computers, and we will learn many terminologies, and I will use those terminologies in the following lecture. So it is really important to know these terminologies. Firstly, we'll talk about what is a computer, and basically we can say a computer is made of hardware and the softwares. So we will talk about them firstly. So what is a computer? Well, people first start to use the word named programmable machines before computer. What does it mean? Well, if you go to, let's say, a factory, okay, they have huge machines. Let's say that it is producing, I don't know, some bottle or some other components, so on. So let's take that with that bottle, okay? So you can use that machine only to produce bottle. You cannot say that, okay, with this one I will also, I don't know, produce tires of a car, or I don't know, or a glass or so. I cannot do it. It's just can be done for glass production. Now, but with the computers is programmable, which means that I can use it for many different tasks. I can use it to write, to watch movie, to, I don't know, to do painting and so on and so on. It is programmable. I just buy one computer and I can use it for multiple tasks. So that's why it can be programmed. And then what is a program? Well, it is a program. A program is basically a set of instructions that tells the computer what to do. And the programmer is the person who does this, who designs and then creates and tests these computer instructions, the computer programs. So it's basically the person who talks to the computer and explains what it has to be done to accomplish a task. And why do we do these programs? Well, it is actually the main goal is actually automatization and speed. So we can I can also draw an image and so on with my hand, but it will take so many hours. Or I can do many calculations. I can do the calculations manually, but it will take so many time. So the main idea is always to do it in an automatic way and speed up our processes. So if you are not even a computer scientist, coming from other engineers, you will see that you will also use many programs. Maybe you might need to write your own program to do also some task related to your field. And well, what is the first computer? Well, Charles Babbage is known as the father of the computers. Well, he is a mathematician, and well, it might be a surprise that actually computers are actually pretty an old idea or a machine. It's not like Charles Babbage actually when he first thought that okay, machines can be also programmed. It was 1830s or 40s. So, but at that time, the technology was not so developed, and at his time he couldn't develop a computer, but he designed it. Like he wrote thousands of pages explaining what it can be, and if it could be done, probably it would be look like this. So it doesn't look the modern computers, but anyway, this is just another information that saying that the programs are not a very new machines. Actually, it has been considered by from a couple of 100 years ago actually. Now, let's go back to our modern computers. So, first, what are a computer is, first we have the hardware stuff. So, what is the hardware? Well, it's components it's the physical devices. It's the device that you can touch and see, which makes the computer, like the monitor, the hard drive, the keyboard, and everything that we can consider them as hardwares. Now, we will talk about them in more detail. Now, the first one is that we have to know is like Central Processing Unit, CPU. So what is a CPU? You might consider it as like the brain of the computer, or maybe the engine of the computer. What I mean is that in a center, the CPU is the program that actually runs programs. So it's actually the main heart of a computer. And if you don't have it, it means that your computer is dead. You cannot use it. And it basically contains two main components. But of course, in modern computers, the architecture is much more sophisticated. But generally, in a very simplified version, we can say that it has these two units. One of them is the control unit, which means it retrieves the instructions and decodes it. What does it mean, decoding? I will explain it in the following slides. And it basically coordinates these computer operations. So you might think it like is the one that decides the what to do next. But of course, when I say that, of course, it doesn't have kind of a free will. It just follows again still the instructions. But its decision also is designed by our instructions. And the other part is the arithmetic logic unit. So it's the part that does all these mathematical operations and the logical operations and so on. Now you might think that, okay, why is this important? Well, everything we do in computer is actually eventually a mathematical or a logical operation. Like when you are even using, let's say, ChatGPT, what's going on behind that is pure mathematical operations or logical operations. So again, now this is the part that does all these operations. Now, when you want to buy a computer, let's say that, okay, this computer has 2.4 gigahertz processor, CPU, and the other one has 3.0 gigahertz processor. What does it mean? Do you have any idea about it? 2.4 gigahertz or 3.1 gigahertz and so on. That is, we'll come to that. This is about now still about the CPU. It is about the speed of your processor. So how many instructions it can process in 1 second. So if it says 2.4 gigahertz, it means that in 1 second it can roughly process 2.4 billions of instructions. So based on that, this is one of the main features that we consider when we are buying a computer. What is the speed of its CPU? What's the speed of its processor? But of course, I don't want to mislead you. The speed of a computer is affected by many things, like your hardware, your hard drive, your CPU, and so on and so on, many things. But of course, so when you buy, and CPU is one of them, but when you are trying to buy a 2 gigahertz or 3 gigahertz, or let's say 1 gigahertz or 2 gigahertz, it doesn't mean that a computer that has a 2 gigahertz processor is necessarily 2 times faster than the 1 gigahertz processor. Because of the other components, it might depend. But usually you can assume that, yeah, it will be somehow faster than the other processors. Then the other part is the main memory. So, and also when we are buying a computer, the other thing that we consider is how much is RAM size. So what is RAM? RAM is basically random access memory. And what is that? It is our main memory. What does it mean is, in RAM, we keep all the data that we need, all the programs that we are running when the computer is running on, when it is turned on. So when you have the electricity, when your computer is running, the CPU is actually using your main memory to keep all the data that you want to use. But it is a volatile memory. What does it mean? It means that when you turn off your computer, the data on the RAM will be gone. Like if you are working on some of your homework assignments and then you forgot to save it, and then the electricity is gone and then your computer is turned off, what will happen is your data, unfortunately, will be also gone. So the contents are erased when the computer is off. But you might say, okay, why is this? Like, why am I losing all the data? Well, it's actually about the speed of the data processing also. We'll come to that once we see the secondary storage. But if you are, shortly, if you are accessing the data using electricity, it is much faster. And we want the speed to do our operations faster way. This is why we use the programs. That's why we use electricity to access the data, and when we don't have the electricity, the data is gone. Now, when we also are buying a computer, now we say that, okay, I heard that, let's say you have 8 gigabytes of RAM or 32 gigabytes of RAM. What does it mean? It means how much data we can keep in a computer while we are using it. And if you are experiencing that, okay, my computer is so slow, I don't know, it became so slow. Is there any virus and so on and so? It might be, but one of the main reasons also usually is that your RAM might not be enough to run all those programs. Like let's say that you have 8 gigabytes of RAM, and then you are now using, let's say, Windows. Windows also takes a couple of gigabytes of that RAM. And then you are opening Word, and then, I don't know, PowerPoint, and then web browser, and then in web browser you are opening so many tabs. And then it means that all of your data should be kept in your RAM. If your RAM is not large enough, then it means that the computer will not be able to keep all that data, and then it has to retrieve that data from your secondary storage that we will see later on, and it is so slow. That's why your computer might become extremely slow at that point. So what you can do is, if you are using especially a desktop, it is actually too easy to increase your RAM size. You can just buy more RAM, and then you can just plug them in your main board, and then probably you will experience that your computer now is much faster than the previous one. So this is again one of the reasons that why we consider RAM size when we are buying a computer. Having a larger RAM will allow you to run larger programs, keep more data when you are using your computer. And when we say that 32 gigabytes, what does it mean? Well, in order to understand it, we need to now focus on more terminology. So in our daily life, we use base 10 numbers. We have 10 digits from 0 to 9. But in a computer works in a base 2 numbers, which means it has only zeros and ones. 0 and 1. So and a bit is basically the smallest piece of memory. So when in a memory, the smallest unit is a bit. In that bit, I can keep either 0 or 1. But of course, I cannot process everything with 0 and 1. I mean, 1 bit will not be enough. So then I put them consecutively, like as you can see here. Then I get a larger number, or I get the different representation. Now I have, instead of having 0 or 1, I have 0 1 1 0 0 1 1 1. So I'm able to write more data in that. So if I put 8 bits together, then I will call it byte. Then what is a kilobyte? 1024 byte makes a 1 kilobyte. Now we can say, okay, why is it 1024? It's not 1024. The reason is that, well, we as a computer scientists, we like the numbers to the power of 2. And 2 to the power 10 is 1024. Of course, it's not like on a preference. There's a technical reason for that. But anyway, so 2 to the power 10 is 1024. And 1024 bytes makes 1 kilobyte. And then 1024 kilobytes make 1 megabyte, and 1024 megabytes makes 1 gigabyte. So when you are buying 32 gigabytes of RAM, it means that RAM can keep, let's count it from here. We have thousands, millions, billions, roughly 32 billions of bits. So I can keep 32 billions of zeros or ones in that RAM if you are buying that kind of a computer. Now, the thing is with the RAMs is that it's good that it is fast. I could easily get the data. So the CPU can process it efficiently. But the thing is, when there is no electricity, it is gone. So, but this is not helpful because I want more permanent data. Like, because you are doing your homework, and then you want to continue at night, maybe you are tired, so you turn off your computer, and then what would happen? Your data will be gone. So this is ridiculous. Of course, it shouldn't be that case. Now, that's why we need also some kind of a storage space that we can use that can keep the data even though there's no electricity. Now, this is a interesting part because how can we do it? Like, computer works with electricity. I need to get the data without electricity. I need to keep the data electricity. So there are some different technologies to do this. Like we have magnetic disks, the floppy ones, the ones that you see on the red. It was, I mean, it exists when I was a child, but I don't think that I don't know if you have ever seen it in real life, but it was the main way to carry the data. Anyway, or the hard disks, not the SD drive, but the hard disks. They also have the magnetic fields or the optical ones, CDs and DVDs nowadays. Even most of the laptops does not even have a CD reader. But anyway, these devices, these methods are able to keep the data without electricity. How it can be done? Well, let me give you one idea about CDs. Have you ever, I don't know, so did you use any CD? Because nowadays CDs are also not very available. But when you take a CD, what you see is that if it is an empty, it will be full shiny. But if it is somehow full, you see that okay, some of its color is different. Why is that? Well, because when we are writing data on CDs, a laser basically makes tiny holes or hole in that to write the data. If there's a hole, let's say it's 0. If not, it's 1. So for all its location, it physically actually damages the CD. But then when you put it in the CD reader, then it can understand, okay, if there's a hole, it's 0 or 1, whatever. If it's not, it is the other one. So we can actually encode our data, zeros and ones, by having those tiny, very little holes on the surface of a CD. That's why if you take a CD and scratch it, damage it physically, you might lose your data. This is because it is physically stored there. Now, this is good actually. This is perfect. Like now I'm able to keep the data without an electricity. Now the question is, then why do I need main memory? Because I lose all my data if the computer is turned off. Do you know the reason? Like, why do I have main memory if it can keep only the data temporarily? Why shouldn't I use this also to keep my data when I'm running the computer? The answer is for 2 reasons. RAM is too expensive compared to these, and also RAM is much faster than these. Like in a CD, if you have a hard drive, when you are running, you will see a sound actually. Something is rotating in it very fast. But it is rotating, it's a physical movement. So it needs to rotate to get the data, to locate the data. It needs to physically rotate. But on the other hand, the RAM, it's just an electricity to access the data. Electricity is much faster than that physical rotation and so on. That's why we are not using these as our main memory when we are running the computer, because they are slow, but they are cheap. That's good. Like you can easily buy like 1 terabyte of hard disk, 2 terabytes of hard disk. But if you want to buy a 1 terabyte of RAM, well, that would be pretty expensive. That would be a supercomputer. So again, RAMs are fast but expensive. Secondary storages are slow but cheaper. Do you have any questions so far? All right. And the other part is now we talk about how to process the data, how to store the data, but the other thing is how to provide the data to the computers. This is called the input devices. So it's basically the devices that gives the data to the computer so that it can process or the stores. So what can it be? It can be keyboard, mouse, I don't know, microphone and so on. All of these actually provides data to the computer. Like For instance, what are the input devices in a modern smartphone? Can you say it, please? Charger. Uh, the screen is like by the screen, yes. There is also one more input device in it, or maybe more, but two. Speaker is an output device. It provides, it generates the sound. No. The microphone gives the sound as an input. The speaker gives it as an output. And also sometimes you might think it as it's like camera. Like if you want to read a barcode or so, you use the camera. So it also provides some input in that. So this can be considered as the input devices. And for the output devices these are the devices that shows the data that is produced by the computer, like the screen, the speakers, or maybe the printer and so on. These are called the output devices of a computer. This part